All right, so let's take it a step further, and since we've already discussed the relationship between pH and pOH, let's dive and we're going to look at the concentration as it relates to pH. Meaning, if we know our hydronium ion concentration, we're going to use that to extract the pH value, and if we have a pH value, we're going to use that to extract our hydronium concentration. Now, the equation for that is as follows, where pH is equal to the negative log of your hydronium concentration. And I've already kind of highlighted this formula, but I really want you to understand how this is applied. And remember, sometimes this could be synonymous with this guy, pH is equal to the negative log, written as your H plus concentration. And really the only difference when you're thinking about it from a written standpoint is this is like saying H and H2O together. You know, so H plus and H2O together relates H3O plus. So that's what they're saying here. So these equations, you know, don't get lost in the jargon when it comes down to these two. So let's focus on how one would go and solve a problem that deals with this. Now, the main thing I tell people is you want to make sure you have a calculator that you trust when solving these problems, because depending on your calculator, the steps involved may be slightly different. But the answer should be the same if you're doing it correct. So let's do a scenario where we're given this concentration and we're asked to find this value of pH. And so I'll just give us a simple number. I'll say that we're given a solution where our H stuff is equal to, I don't know, 1.6 times 10 to the negative 8. And I'm curious, is it an acid, is it a base, is it neutral? Is it acid, base, or neutral? And remember, if it's acid, it's going to have a pH less than 7. If it's base, it's going to have a pH above 7. And if it's neutral, it's going to be really close to 7. Now, some of the questions I get asked about that neutral value is, if it's like, I don't know, like 7.1 or 7.12, are you considering that neutral? I probably would. That's just kind of the side I would lean on. Technically it is over 7, but it is still in that neutral realm. So definitely, if there's a question asked about if something is acid or base, high end at least, I'm at least trying to give you a little bit of a variation where I'm saying you got a value of 8.9. Is that acidic, basic, or neutral? You know, that's going to mean that it's basic. So let's go ahead and look at solving this problem. Now we know that concentration, and I should go ahead and give you a value here with an italics M, which suggests molarity. Now, if you know anything about molarity, that means they can go inside these brackets, because those brackets mean concentration. So we're going to take this equation, and we're going to say pH is equal to the negative log of our concentration of 1.6 times 10 to the negative 8, and I'm going to close that bracket. So now I want to find this mathematically. Now, it might seem like a daunting task, but again, it helps when you have a calculator that you trust. This is mine, and I'm going to use that to solve it. Now, depending on your calculator, you're going to have a different series of buttons. With some calculators, you can put it as in. You can put negative log 1.6 times 10 to the negative 8 and keep it moving. Some others may have to put in log 1.6 times 10 to the negative 8 and then apply the negative symbol. And I've even seen cases where they have to put the number in first and then press log to get the answer in question. For us, I think it's a little bit easier where we can put log or we can do negative log. I tend to forget that and put the negative because I can tack it in on the end, or I need to just keep this in mind that my pH value is positive. So if I get a negative value, I'm looking for a positive pH for my answer. So if I'm getting a negative answer, I just need to, remind myself, pH should be positive, it shouldn't be a negative number. So I take my 1.6, and here's a little bit of calculator information if you didn't know. Instead of typing in times 10, what I do is I prefer to touch up on this EE button. Now some of you guys might not know about the EE button. I'll see if I can zoom in a little bit, if that gives it a little bit more clarity. It looks like it didn't really add that much to it, but I'll point to it nonetheless. But I'm going to say that this is my EE button, the blue button here on this column. So in the scientific graphic calculator I have, I'm going to press second, and then I'm going to press the comma, which is EE. and E means times 10. So then I'm going to put E, and then I'm going to raise it to the value that I have here. I have it raised to the -8, so I'm going to put I'm going to press the negative symbol, not minus. I'm going to put -8, and then I'm going to put a closed parenthesis. And then I'm going to press enter, and as you can see, it gives me an answer that is negative. Now, remember, I didn't put my negative log in front of it. Also keep in mind, pH must be positive. So even though I'm getting a value of negative 7.79, what I'm really seeing is more like 7.80 because I'm rounding up. So 7.80. And so you're asking the question, Dr. Sims, is that 7.8? Is that neutral? Is that basic? Is that acidic? Well, you know me, since I'm thinking that that's really close to the value of 8, I'm going to lean on the side of this being considered basic. So this is my pH value. So if I want to find my pH, all I had to do was plug in that number, take the log of it, and it gave me my pH value, and I'm able to say that it is a basic solution. The next question obviously should come is, what if I'm given the pH value and I'm asked to solve for this concentration here? So let's come up with a pH value. Let's say that our pH value is equal to 3.23. So we have a pH value of 3.23, and let's say that I really want to find out what the hydronium ion concentration is. I want to know what that is. Well, it is still the same equation, which is pH is equal to the negative log, but you have to take a different approach when solving. Before, we just plugged it into this equation and we're able to keep it moving. But we have to change that up a little bit. What I tell folks is to think of it like this. And I can tell you the steps to get into it, but really I think you just kind of want to know the formula. Now, there's two formula approaches you can put in your calculator. One is you can do 10 and raise it to the negative pH value in question, and that'll give you this guy here. That's one way of doing it. 10 and raise it to your negative pH. And a lot of people find that that's the more simplistic, more approachable way of looking at it. Some others take it and put in second log, and then they put negative pH to get their hydronium ion concentration. And it's really just meaning the same thing in terms of you solving it. It just depends on your calculator preference. Now, if we have that value, you can get the answer either way. And if you really want to know how we get to that, it's basically mathematically you apply negative antilog to this side and this side, and then you do some math, and then you end up raising that value that got to negative pH. So remember, this setup allows us to solve for our brackets of hydronium ion concentration. The one we looked at before allows us to solve for pH. And so you want to have this in the back of your mind, which of these two do I really want to use? They're technically supposed to be the same equation, this guy and this guy, but some people it helps to register it as being this separate equation from this. So there's that component. Now, let's apply the first value, or first way of doing it, and say 10 raised to our negative 3.23 should give us our concentration. That's what we're looking at, 10 raised to the negative 3.3. So then the question is, how do you put that in the calculator? Well, in my calculator, I'm going to put 10. Then I'm going to press the little chevron sign that looks like it's pointed up here. And then I'm going to put in negative. And then I'm going to put in 3.23. And then I'm going to press enter. Now, when I press enter, it gives me this long number, 5.88, blah, 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 E negative 4. Now, when you see this E, is like I said before. The E means times 10. So written, I'm writing out 5 point, and I'm just going to use three numbers. I'm going to use 5 5.8, and I'm going to round that 8 up to a 9, the next one, and then raise that times 10 raised to the negative 4th power. And that's going to be the value for this guy here. And that's how I get that. So I take this, and that's my value for my answer. So all I did was put in 10 negative 3.23. Now, as I mentioned, there's more than one way to do it, which for some people it might be the first way. Another way you could do it is if you did second log, it gives you the same kind of scenario, and then you type in your negative 3.23, and you're getting the same answer. So it's up to you which buttons you press on your calculator. I think a lot of people like just doing 10 and raising it to that value because second log really means the same thing in this particular case. So that's how we go about solving those problems when we have pH. But here's the question. If you have a value and you're dealing with pOH, how does that change things? What does it look like when you have pOH? Because we've talked about the relationship between pH and pOH. We talked about pH, but there has to be a way of calculating your OH concentration or your pOH. And that's when you enter in with this equation here, where pOH is equal to the negative log of your hydroxide ion concentration. So the formula should look very familiar to pH. The only difference is that we're dealing with your pOH. And usually you're using this equation when you're operating with bases. So this is kind of the base side of things. And again, you want a positive value for your pOH. Your pOH should be a positive value. We're only working with positive numbers. So how do we go about solving it? Well, we're going to do the same thing we did before. I'm going to give us an OH concentration, and I'm going to set that OH concentration equal to 2.39 times 10 to the negative, let's do negative 12. And I'm just arbitrarily making up numbers. This is not like some number that you're supposed to know or something like that. I'm just pulling arbitrary numbers, random numbers, to solve these problems. Now, we know the setup for how this is solved. We say that pOH is going to be equal to the negative log of your 2.39 times 10 raised to the negative 12. And so we've done something like this where we put it in our calculator. And so I'm going to show you once again how we go about doing that. You take your calculator, and in your calculator, you can either put the negative log in front, or you can just put log. Either way works. I tend to just forget to put the log sometimes because I know my value has to be positive. So log 2.39, and once again, what I got to do is if I want to raise it to that 12th power, what I'm going to do is I'm going to press second, and then I'm going to press my comma button, which has the EE, and then I'm going to raise it to a negative, not minus, a negative 12. And then I'm going to close my parentheses. And then I'm going to press enter. Now for some calculators, you might have to put the number in first and then press the log button. It just really depends on how your calculator functions. And then I'm going to press enter. And it's going to give me a value that is negative 11.62. Now what did I say about my pOH value? Just like my pH has to be a positive value. So that means that my answer is going to be 11.62. Now, here's the trick question. Is this acidic, basic, or neutral? If you think this is basic, then that would be incorrect. Remember that relationship about pH and pOH? Well, with pH, if the pH is greater than 7, it's basic. But if it's less than 7, it's acidic. But the roles reverse when you have pOH. So if a pOH value is less than 7, it's basic. And if the pOH value is above 7, it is acidic. So this is acidic because of the pOH, because pOH. So remember that, pOH greater than 7. So that means it's acidic. Now, just like I did before with the other problem, where we were able to find the pOH, I want to look next at solving for your OH concentration. That's what I want to solve for. Because what we did was solve for POH already up here. That's what this is. And now we're going to solve for our OH concentration. So we're going to use another number that I'm going to randomly pick. And I'm going to pick the number, 1.72. And I'm going to say that's equal to my POH. And I'm going to say, hey, what is my OH concentration? I don't know what that is. So I want to find out what that's equal to. And to do so, we have to go about doing the same thing we did before. Now, last time I said we do 10. We're going to raise it to the negative POH value, in this case, and that should give us our OH concentration. Another way you look at it is second log and then negative POH, and that's going to be equal to our OH minus. So it just depends on which calculator you use. You just want to make sure you have a calculator that you trust when everything's said and done. And so rewritten, the equation would look like this. 10 is raised to the negative 1.72 value, and that's going to be equal to my hydroxide concentration. Now, when I put that in, I'm going to just type in 10. I'm going to press my chevrons on here, and I'm going to raise that to my negative 1.72. And then that's going to give me my concentration, which in this case is equal to 0.019, and I'll say 1 to round up, and that's molar. And that is equal to the hydroxide concentration. Now, these two are very similar. If you know your pH and you want to find your hydronium concentration, use the equation. Same thing with having hydronium and trying to go to pH. Here we talked about POH and going to hydroxide, and having hydroxide and going to POH. And it really just depends on that need. But that represents almost 4 different sets of math that we've used to kind of broach the subject. Now, when it comes down to that, one of the things we also need to keep in mind is that sometimes you will get problems where you're given the pH and you're asked to find another value like your hydroxide concentration or something like that. So here's what I'm proposing. We're going to look at some examples where you have a scenario where you're given your pH and you're asked to find your H, then we're given our pH to find our hydroxide, and then we're going to look at another one where you have your pH to find your POH. All right, so if we're looking at this, to find the pH, we've already said that if we have the value, we know the equation is pH equal to negative log of H plus. Well, here's what we're going to do. We're just going to plug our number in. We're going to say pH is equal to the negative log of 1.36 times 10 raised to the negative 9. And so then we're going to put in our calculator just like we did before. So to put in our calculator, we got to remember that if we get a positive value, that's what we're going for, because it has to be a positive value. This time I'm going to show you with the negative log. If you do negative log and I type in 1.36 second, comma, for E, and raise it to the negative 9, close my parentheses, and I try to solve, I'm going to get a pH value that is equal to 8.87. And parentheses I'll put, that's basic. Because remember, our pH, if it's above 7, it's basic. So then we're going to look at the next one, which is not related at all, random problem, and we're given our OH concentration or hydroxide concentration. So here's what I'm proposing. I'm proposing 2 steps for this here. Step 1, I'm proposing going from OH concentration to POH, and then I'm proposing going from POH to pH. So let's try that, shall we? If we recall, whenever we're given our hydroxide ion concentration, we just can plug it in the simple equation POH is equal to negative log of hydroxide concentration. So I'm going to go ahead and rewrite that with the actual number featured. Negative log of 3.86 times 10 raised to the negative 8. And then we're going to solve. So once again, I'll get my calculator out. I'll say negative log of 3.86. I'll press second, comma. I'll raise it to the negative 8th power, because that's what we have here. I'll close my parentheses, and then I'm going to press enter. And that's going to give me a POH value that is equal to 7.41. Well, if my POH is 7.41, I pull on the second part of this, which says that pH plus POH equals 14. So that means that if I already know my POH, I should be able to just take 14, subtract 7.41, and that'll give me my pH. So I'm moving that number, putting that there, and then it's 14 minus 7.41, and that equals my pH. So mathematically, if I take my 14, subtract 7.41, I get a value of 6.59 is equal to my pH. And because the pH is less than 7, this is going to be closer to acidic. All right? And you might be tempted to say it's neutral if you want, but I'm leaning acidic on this guy. Now, the last one is a simple one, and I almost feel like this one should have been like the last one. But here we are given a question where you're given your pH and they want you to find your POH. And like I said, 14 is equal to your pH plus your POH. So if you know that, that means that 14 is equal to pH plus 7.5. So you know that 14 minus 7.5 should give you your pH value. So how do we do that? We take out 14, subtract 7.5, and the pH ends up being equal to 6.5. And so this, again, is acidic. And so we've tackled kind of these 3 practice problems, and hopefully that helps register your knowledge regarding acids and bases.